Alright, so let's look at another question. So this looks almost similar in arrangement to the former question, but it is actually very different. So we're being told to evaluate the integral of 1 over sine x times cos squared x dx. So how do we solve this one in this case? So as I've said, it's different from the initial one, but it's also possible to work out. So in this case, the first step, we can actually see that where we can see what we're going to do is convert this. So remember that 1 over cos squared x is actually the same as sec squared x. So we're going to have it as sec squared x over sine x dx like that. Next, we remember that sec squared x is actually the same as 1 plus tan squared x dx. And then I can see that I can now split this into two different integrals. So I'll have 1 over sine x plus tan squared x over sine x. And this is okay, that's correct. And then basically what I can see that the next step is I can convert this tan into the form of sine and cos. So what will I have? So I'll have sine squared x. So tan squared x is actually sine squared x over cos squared x. Now we will have them dividing this sine x, as you can see right there. But now that division sign, if turned into a multiplication sign, is going to be equal to 1 over sine x, of which you can see that this and this will reduce, and then I'll end up with the integral of 1 over sine x plus sine x over cos squared x dx. So now this is going to be easy to work out. So now I'm going to separate these into two different integrals, of which we're going to solve them. Now, as I can already see here, this is actually going to be easy because 1 over sine x is actually cosec x, so this shall actually be easily integrated. Then right here I can actually say that we shall actually use u substitution, where we make u to be equal to cos x, and then we'll get a value where which will cancel out with this sine x, so everything will now easily be worked out. So as you can see, 1 over sine x is cosec x, and then this remains as sine x over cos x. So let's solve for each one individually. So for the integral sine x over cos squared x dx, I'm going to let u to be equal to cos x, and then du dx is equal to negative sine x. So if I make dx subject, dx shall to be equal to negative du over sine x. So therefore, if I substitute everything back, so where there is dx, I actually put this, I'll have this sine x over u squared times negative d over sine x. So this and this will cancel, and we'll have no x values left, which means we've actually chosen the right value to make u. So I'll have negative into the integral. Of course, this can be converted as u to the power negative 2. So the integral of that is going to be equal to u power negative 1 divided by negative 1, which is actually the same as negative u to the power negative 1. I mean, it's actually negative 1 over u, but because of this negative on the outside, I'll have a positive 1 over u plus c. But remember that u is cos 4x, so therefore our answer for this is 1 over cos x plus c, which is actually the same as sec x plus c, because 1 over cos x is sec x. So for the other side, for the integral of cosec x dx, so remember earlier in this section, I'd actually shown you a method to actually integrate this cosec x. I told you it's quite different because of what we actually have to select for u. But we remember that the answer we got was ln cosec x minus cot x plus c. So therefore we have the integral of 1 over sine x times cos squared x dx should actually be equal to ln cosec x minus cot x plus sec x plus c, and that is our final answer.